Information System at Birla Institute of Technology and Science, BITS Pilani Campus, India. Moreover, he was associated with Intel Technology India Private Limited. He received his PhD at BIT Mishra, Ranchi, India under the supervision of Dr. Desh Kumar Mali. The main field of his research interests include ad hoc and wireless sensor networks, soft computing, and deep learning. He has contributed many research papers in international peer-reviewed journals and conference proceedings in the above mentioned areas. Sir, it's an honorable moment for our institute to have your prestigious presence today event. We are truly inspired by your deeds. I hereby request Dr. Behoshoni sir to enlighten our minds with his expert talk. Sir, please welcome.
Thank you so much, sir, for the introduction. So, sir, should I share the screen first?
Yes, sir. Please.
Okay, just give me. Okay, so is this screen visible?
No, sir. Right now. Yes.
Is visible now?
Yes, sir. You may proceed, sir.
Okay, sir. And the slides are also changing, right?
Yes, sir. Moving slides, sir. Please move.
Okay, sir.
Okay, sir. Thank you, sir. You may start.
Okay. Before I start, I would like to thank to Dr. Dilip Kumar Chaube, who is working as an assistant professor in the Department of CSE at IIIT Bhagalpur. And I would also like to thank the entire CSE department of CSE department of IIIT Bhagalpur for approaching me for such a meaningful and wonderful short-term course on artificial intelligence and data science in healthcare. And today I will be giving a brief idea about deep learning-based human activity recognition in healthcare sector. So without any delay, let's start with the introduction of HCR first. So human activity recognition is an important area of research in human behavior analysis and human-computer interaction. The focus of this presentation is to provide in-depth summaries of deep learning methods for mobile and wearable sensor-based human activity recognition. So human activity recognition can also be referred to as HCR. HCR is nothing but the short form of human activity recognition. And in human activity recognition is a broad area where different type of problem statements can be achieved. So this lecture will be presenting the methods, uniqueness, advantages, and their limitations also. Further, this presentation will also present classification and evolution procedures and discuss publicly available data set that we can use for our research related work for mobile sensor human activity recognition. So we will be mainly focusing on data collected by mobile sensors. We will also be giving a brief idea about the data set that can be collected by camera type of sensors. Okay, and somehow we will also be able to distinguish between these two type of data set, and we will also be discussing the advantages and challenges involved in collecting of those data set. I will also explain some challenges to open research problems that require further research and improvements. So human activity recognition systems are developed as a part of framework to enable continuous monitoring of human behavior. So that I already mentioned. And then number of applications where HCR can be used, like a sports injury detection, elderly care, rehabilitation, entertainment. So there are number of applications where HCR can be used. So it totally depends on the problem statement and the data that you are going to use for your research work, right? So suppose if I want to provide the best possible action for a bowler, right? So HCR can be used. If I want to detect any disease or that any elderly can be diagnosed with, can also be one of the problem statement of HCR. So there are a number of applications where HCR can be applied. So it is a very active research area in recent years due to the rise of ubiquitous computing enabled by smartphone, wearable devices, and Internet of Things. So as you can see, there will be the involvement of smartphones, wearable devices, and Internet of Things. So Internet of Things can be involved when all these are divided, all these are devices somehow connected to each other through some common platform. Uh, Now, researchers have this figure shows categories of deep learning in sensor-based human activity recognition. So as you can see, there are number of problem statement you can start with, like class imbalancing, distribution, composite activity, data segmentation, concurrent activity, multi-occupant activity, computation cost, privacy, interpretability, feature extraction. So there are number of problem statement you can start with, and feature extraction is one of the most basic and important what step of HER, right? So if you just started working on deep learning, so there are two type of problems you can start with: either the feature extraction, where you can perform number of segmentation type of techniques, or you can also achieve classification based problem, where you will be able to distinguish different possible activity performed by any particular user or person. So researchers have proposed various human activity recognition systems aimed to translating measurement from smartphones into various types of physical activity. So physical activity can be like walking, running, sitting, jogging. So these kind of activities can be classified using deep learning models. Recently, as deep learning has demonstrated its effectiveness in many areas, plenty of deep learning methods have been investigated to address the challenges in activity recognition. So in most of the area, deep learning can be applied. So in this paper and in this lecture, we will present a survey of the state of the deep learning methods for sensor-based human activity recognition. So the entire presentation will somehow be focused on deep learning methods involved in human activity recognition. So sometimes I can also refer this human activity recognition just as HAR. Okay. Now there are a number of challenges involved in HAR. The very first challenge is feature extraction. So activity recognition is a classification task. So as I already told, there will be different type of activities, and out of these activity, you need to identify that particular activities with better accuracy. So whenever your deep learning model is able to identify any particular activity, it will be considered as accurate model. So it shares a common challenge with other classification problems. So in that case, whenever we are talking about any classification based problem, so there will be common challenges even with classification type of problem statement in HAR. So feature extraction is one of the most common challenge that you have to consider. So for sensor based activity recognition, feature extraction is more difficult. Why? Because there is an inter-activity similarity. So there is a possibility where two different activities might be similar in terms of their characteristics. Now, suppose if I consider two different type of activity like walking and running. So whenever we try to collect these data set for these two type of activity, the data set will be very similar in terms of connectivity, in terms of characteristics. So in that case, feature extraction can be more difficult for very similar but different activities. So we have to be very careful at the time of feature extraction. But with the help of deep learning, there is a possibility that this particular part can be done automatically. But still, there is a challenge whenever we try to collect our own annotated data set. The next challenge is annotations scarcity. So training and evolution of learning technique requires large annotated data sample. However, it is expensive and time consuming to collect and annotate sensory activity data, because the number of features, the number of data will be more. So this is the reason the annotation might be a bit expensive and time consuming, but it will be same for each and every type of a problem statement. So whenever you try to collect your own data set, you always have to go this, you also have to go through this step. But suppose if you are going to use any publicly available data set, everything will be available to you. Okay. Now class imbalance. Class imbalance, there is a possibility. Suppose if I say, if I'm going to collect any data, right, and suppose there will be weightage of different type of activity. Now suppose if I'm trying to consider different activity, out of which almost 50% of the data is just for walking, and only 10% of the data just for sitting, or some for moving upward or downward. So in that case, as you can see, there is a class imbalance. So some data, some particular activity can what can completely you can say the 50% of the data set is just for one particular activity, while there will be some possibility where any particular activity is only having 5% of the total data set. So in that case, there will be class imbalance. So in that case, what you can use some balancing method in order to resolve this issue. So you can, there is class balancing technique is also one of the problem statement that you can consider if you are interested working in the field of HCR. Then distribution discrepancy. So HAR involves three factors: user, time, and sensor. First, activity patterns are person dependent. Different user may have diverse activity style. So there is a possibility where even for the same activity, you might have a bit different data set, a different pattern for different users, because every person will be having a different activity style. So in that case, for the same activity, for two different person, you might have a different diverse pattern. So in that case, you also have to handle this problem. But you can say you will be able to design some deep learning model that can simply what address this particular type of challenge. Second, activity concepts vary over time. So there is a possibility if I'm going to collect data set for the same person at this point, and after 2 years, the activity can change. So there is a possibility if there is a young person and there is an old person, the pattern can change, right? So the assumption that user activity pattern remain unchanged for a longer period is impractical. Moreover, novel activities are likely to emerge when it is used. So suppose if I'm considering the same person for collecting data, so with time, there is a very less chance where the pattern will change, right, for a shorter period of time. But suppose if there is gap of 5 years or 10 years, obviously the pattern will change, right? But suppose if I'm going to collect the same data set for the same person, there is a very less chance of changes in pattern. Third, diverse sensor devices are opportunistically configured on human bodies are in environments. So the composition and the layout of sensors dramatically influence the data stimulated by activity. So in that case, we have to find out the appropriate position where we can integrate our data, integrate our device, or place our data, place our sensor devices. So it can be either any person can wear any sensor on waist or on wrist or some other place of the body. So in that case, the appropriate position of the sensor will also be very critical at the time of collecting any data set. So all the three factors lead to distribution discrepancy between the training data and test data and need to mitigate urgently. The next thing is data association. So it refers to how many users and how many activities the data is associated with. The complexity of data association is another reason that makes recognition challenging, right? The next thing is composite activity. So most activity recognition tasks are based on simple activity like walking and sitting. So whenever we are considering some basic activity, there will not be an issue. But suppose if I'm considering some task where there will be the involvement of different type of activities. Suppose if you are soaping, rubbing hands, turning off the lamp, so there will be a number of activities that will be involved for the same activity. So for those kind of activity, it will be a bit complex. So in that case, what you can do, you can simply consider only different type of activities. Those are somehow different in terms of characteristics. The next thing is data segmentation. So one challenge is data segmentation. So composite activity can be defined as a sequence of activities. Therefore, accurate recognition highly relies on precise data segmentation technique. So data segmentation technique is very critical, very crucial after collecting of data set. So you always have to go through this particular step because the data cannot be collected very better way. So in that case, you can perform some steps such as data segmentation in order to clean your data before deploying any deep learning based model. Okay. Now what concurrent activities? So it shows the third challenge, which is concurrent activities occurs when a user participates in more than one activity at the same time, such as answering a phone call while watching TV. And suppose if I'm using a mobile phone while walking, while running. So in that case, there is a possibility where the same person might be involved in two different type of activities at the same time. So at that time, the pattern will not be very accurate. So whenever we are trying to collect any data, we will always be considering the ideal scenario where the person can only be asked to perform any particular activity. But suppose if we talk about real world scenario, any person can be involved in more than one activity at the same time. But we should be able to propose a model so that it will also be considering those kind of scenarios or challenges. Okay. Then computational cost. Computational cost is very important, because whenever there is a possibility, you can create very complex deep learning model, but the total time complexity will also be same. So this is the reason we need to design some deep learning model which should be very effective in terms of computation cost. The next thing is privacy. The main application of human activity recognition is to monitor human behavior, so the sensors capture the activities of user continuously. So hence there are risk of personal information disclosure. So whenever we are considering any data set, and whenever we are placing any video for publicly available data set, there is a possibility where we can also be intruding their privacy, right? So privacy will always be a challenge that should be considered at the time of collecting any data set. And we also need to take the consent from each and every object before at the time of collecting their data set. The next step is feature extraction. So as I was told, so feature extraction is very important. So just give me a minute. Okay. Now, what is feature extraction? The extraction of relevant features is most challenging part of the mobile and wearable sensor-based human activity recognition system. So mobile and wireless sensor-based is why? Because in most of the cases, either we can use some sensor-based device, or we can just use mobile, because the mobile will always be having those kind of sensors within it. So what we can do, either we can use some sensor specifically designed for collecting that data set, or we can also use a mobile phone that can be placed somewhere in the pocket, right? So mobile phones is very important device for collecting any particular data set for human activity recognition type of problem statement. The feature extraction influences the algorithm performance and reduces computation time and complexity. So obviously, whenever we talk about feature extraction, somehow it will be about influencing the overall performance of the proposed model, right? And there is also a possibility it can also reduce the computation time and complexity of the model, because at that time we will only be focusing on only important and selected features from the collected data set that can actually be required to perform that particular objective or that particular type of challenges, right? So with the emergence of deep learning and increased computation power, deep learning and artificial intelligence methods are being adopted for automatic feature learning. So there is a possibility the same thing can be done automatically by using the help of deep learning model, because as you know, the feature extraction and the classification have been combined together in deep learning model. In case of machine learning, there are two different steps. First of all, we have to perform feature extraction manually, after which we can deploy some particular model for performing some classification type of problem. But in case of deep learning, the feature extraction as well as the classification can be done at the same time, and it can be done automatically by the help of any deep learning based model. Now, deep learning models have become very popular for feature extraction and classification of simple and complex human activity recognition in mobile and mobile and wearable sensors, right? So deep learning, this is the reason either you can work in the field of feature extraction or classification based problem using deep learning for the same problem statement. Okay. Now, previous studies in HAR can be broadly categorized based on diverse devices, sensor modalities, and data utilized for detection of activity details. These includes video-based, wearable, and mobile phone sensors, right? So in this case, video-based is where we are going to deploy any particular camera sensor, right? So in that case, you will be collecting a vision-based data set. And whenever we are talking about mobile and wearable sensors, in that case, we will be collecting time series type of data set, right? So whenever we talk about video or images, it means the size of the data set will be more, right? And whenever we talk about time series data set, the number of data set will be more, but at the same time, the size of the total data set will be less. So it will be better to use time series data set due to some advantages. So in most of the cases, whenever we talk about HAR, whenever we are working in the field of HAR, we will mainly be preferring wearable and mobile phone sensors, as long as you don't have a dedicated workstation at your locality or in your organization. So video-based sensors are utilized to capture images, videos, and surveillance camera features to recognize daily activity. So there are type of features you can collect, type of data you can collect. So with the introduction of mobile phones and other variable sensors, initial sensor data are collected using mobile or variable embedded sensors placed at different body positions. So in that case, what we can do, we can place those sensors at different body position depending on our need, right? In order to collect the same type of data set. Now, we will be focusing on the differences between mobile and video-based data set, right? So, video sensors extract features such as histogram oriented gradient. So, these are some of the features that we'll be considering whenever we are trying to collect any images, videos, or some different type of data set from some any video type of sensors, right? So these are the main features that will be considering as an input for any deep learning based model. On the other hand, mobile sensors utilize statistical and frequency based features to recognize activity recognition. So in that case, what we do, we will simply be collecting the time series bit data set. So we will be getting a Excel file, a .csv file, where there will be number of features can be extracted from different type of sensors available in equipped in mobile sensors. So it has been noticed statistical features provide less computation time and complexity. So it would be better for us, right, to consider time series data set, a data set created by mobile sensors or any other sensor, variable sensors, in order to achieve less computation time and complexity for the same model. So vision based techniques improved on user privacy, because somehow we have to deploy any camera, right? So in that case, there is a possibility we will be including the privacy of any particular user, right? And it will also require fixed location implementation and capture non-target information. So there is a possibility we have to deploy the same number of camera sensors, and depending on the total number of instances, the cost of those devices will also be high. So in that case, in terms of costing, it will also not be a good solution for it will also not be a good scenario for us. So it would be better to consider only sensor based devices, so that we would be able to collect all those data very cost effectively. In addition, video sensors based HAR are affected by lighting variability, leading to decrease in performance due to visual disturbance. So we cannot always consider the ideal scenario. There is a possibility where the collected data can be affected by any visual disturbance. So at that time, the data will not be acceptable for our data, for our model. So suppose if I'm going to collect any data in your lab or in your room, everything will be in the ideal scenario. But when you start collecting data in some open environment, there will be some visual disturbance. So at that time, it can also affect the overall performance of your system. On the other hand, mobile and variable sensor based methods provides better advantage for real-time implementation of HAR system, right? Moreover, mobile phones and wearable devices are not location dependent. So at that time, I already mentioned we have to place all those camera sensors in some fixed location. But in case of wearable sensor, these are not location dependent. So either you can keep it in your pocket, the right pocket, the left pocket, or you can also keep it on your side pocket, or you can also keep holding it at the time of walking. So at that time, the way of the data is being collected will be different. But at that time, there will not be any dependency on the location of any wearable devices. And somehow it will also be cost effective, because the cost of any normal sensor will be very cheap, right, compared to any camera sensors. And they will also be easy to deploy. So you can simply keep all those sensors somewhere in your pocket. Okay. Considering the obvious advantages of mobile and wearable sensor based implementation of HAR, number of studies, a number of research papers have been proposed by leveraging on the data generated using these devices. So when you start looking for number of papers, or when you start looking for papers, the number of research papers, those have considered that type of data set. I will also be giving some example of data set that you can consider for your research related work. Okay. Now this diagram shows the overview of a standard smartphone sensor. So as you can see, there are inertial sensors such as accelerometer, gyroscope, magnetometer. Those are the main what sensors which are important to collect these kind of data set. So those will be collecting measurements with respect to three orthogonal axes, which are nothing but x, y, and z of the body of the phone. So in that times you will be able to collect all required sensor for your data set. So these are some important what give me a minute whether I can use pen or not. Give me a minute. Okay, so as you can see, there's an accelerometer, there is a gyroscope, and magnetometer. So each and every almost every smartphone devices will be having these three type of sensor, and the data collected by these sensors will be sufficient enough to start working in the field of HAR. Right, the remaining sensors are orientation invariant. So the rest of the rest of the sensors will not be and not might not be very important for you guys. Okay, so in that case, accelerometer, gyroscope, and magnetometer will be more important for collecting those kind of data set. Those are actually required for HR kind of activity. Okay. Now this diagram shows the recognition process, right? So to the left are the sensors that are sensors of data required to recognize activity. So as you can see, these are nothing but different type of sensors. Those will be required to recognize different type of activities. Okay, so whereas to the right are activities of daily living that are required that are recognized by the activity recognition chain. So as you can see here, right, activity recognition chain, and these are nothing but different type of activities like as you can see jumping, sitting, uh, using staircases, running, and walking. So these are different type of activities that you can recognize by using any classification based model, right? So the most commonly used sensors I already mentioned are nothing but accelerometer, gyroscope, and magnetometer. So these are the sensors those will be required for collecting these type of data set. The potential recognition activity vary in complexity. So in this case, as you can see, walking, jogging, sitting, and standing are example of the most simple ones. While preparing a meal, shopping, taking a bus, driving a car are example of the most complex ones. Depending on the complexity, different techniques and types of signals are implemented. So this is nothing but the pattern for the collected data set, as you can see. So these are nothing but the pattern. And this is where you are going to deploy the deep learning model. And after deploying deep learning model, you will be able to classify different type of activities. And this diagram is nothing but the data set collected by these kind of sensors, right? So this process is called data equation, and after which you have to go through these four type of steps. The first one is pre-processing, because what happens whenever you have collected any data set, it will not be always clean, right? Depending on the type of data set, you have to go through number of pre-processing technique. So in that case, some standard pre-processing technique can be required. After which you have to go through data segmentation. I always tell, whenever you are going to start working on some own collected data set, some data set which is not very clean, these two steps will be very important. After which feature extraction is another activity step that will be required. In that case, you have to consider only important features that might be affecting the overall performance of the deep learning model. And the last step is nothing but the classification. Classification is nothing but the final result of the applied deep learning model. So it will be able to identify which particular activity is being performed by the user. So in this case, it will be shown as the user is using staircases to go up or down, right? So classification is nothing but a type of problem statement where you will be able to classify, identify any given from any given number of classes, right? So in this case, there are 5 different classes: jumping, sitting, using staircases, running, and walking. And out of which you have to identify any particular kind of activity using the same model. Okay, give me a minute. Wait.
Sir, your voice is not audible.
Sorry.
Your voice was not audible. Okay, sir.
So 1 second. I think there was some problem.
Okay.
I'm resharing the PPT.
Yes.
Just give me a minute, sir. So is the screen visible now?
Yeah. Yes. Yes.
Okay.
Yes.
Now, uh,
Yes. Yes.
the next slide is on different steps involved in activity recognition process. So as you can see, the very first step is nothing but data acquisition, where you will be collecting data set from using different type of sensors that I already mentioned. The next step is pre-processing. The pre-processing step is responsible for removing artifacts and noises, right? So generally pre-processing is based on filtering technique. So where you will be removing some any non-important features, those might not be required for your deep learning model. After which the next step is data segmentation. So this particular step is mainly responsible for splitting data into segments, and sometimes it can also be referred to as windows. So data segmentation is a common practice which facilitates the next step. So in most of the time, whenever you are working on any time series data set, the pre-processing and data segmentation will be more important steps. Those will also be important for most of the data set. The next step is what? Feature extraction. So feature extraction steps aims to extract the most significant portion of the information from the data to given to the classification algorithm while reducing data dimension. So suppose if I'm going to collect any data and number of sensors are involved, it means you will be collecting very large set of data set. So there is a possibility out of the collected data set, only 50% of the data is important for our deep learning model. So in that case, what we can do, we can simply remove the remaining 50% of the data, and we will only be focusing on important features. Those are mainly important to identify that particular activity. So feature extraction is very important, where you will mainly be focusing on very important features. Those will somehow be affecting the overall performance of the deep learning model. And the last step is classification, where the model will be able to identify any one particular type of activity among all other classes. So as I already gave one of the example in previous slide. So I will not be covering the detail again. Okay. So as you can see, this table shows some important publicly available data set for human activity recognition. So wisdom, UCHAR, opportunity. So currently we are working on wisdom, UCHAR, opportunity, PAM2, right? There are also some variation of UCI, as you can see, UCH, HAMT, UCA, MHAD, HAR. So these are some of the very popular data set you can start with. So I will also be sharing one link with you where you can start working where you can start working on the implementation part. And for that particular example, UCHA data as UCHA data was considered, and you may also find number of source codes where wisdom dataset is involved. So these are some of the dataset you can start with. So for example, wisdom, UCHAR, opportunity, PAM2, mHealth are some important dataset that you can consider. And currently, we are also using 5 or 6 dataset for our research work. Now, uh, there are a number of performance metrics in order to evaluate the performance of any model. Okay. So the very first thing is what? Give me a minute. So as you can see, there are six performance metrics that you can consider to evaluate the performance of any deep learning model. The first one is confusion matrix, then accuracy, F1 score, recall, precision, and ROC curve. So if you already have experience in deep learning model, you must be aware of these kind of performance metrics. So whenever you are going to deploy any deep learning based model for classification based problem, these are very common performance metrics that you can consider for comparing the performance of different models. Okay, so in this case, I will be considering some of these. The very first one is confusion matrix. Okay, so as you can see, in supervised machine learning, the confusion matrix compares the ground truth, right, with the estimated label. So the binary case is shown in the table. As you can see, there are only two possibilities: the ground truth. So either it can be 1 or 0, and there is an estimated, which can again be 1 or 0. So as you can see, there are four possibilities: true positive, false negative, false positive, and true negative. So if I want to know the details of a confusion matrix, you can go, you can refer some of the resources. But you need to know, whenever you are going to deploy any deep learning based model for classification type of problem statement, these are the performance metrics that you should always consider in result and simulation section, so that you can compare the performance of different models for the same or different type of data set. Okay, the next thing is accuracy. So the accuracy is the most used metric for evaluating the performance of classification performance. According to the confusion matrix showed in the previous slide that we just showed, right, accuracy can be defined using this particular equation. So TP is nothing but true positive, TN nothing but true negative, FP is nothing but false positive, and FN is nothing but false negative. By using this formula, you will be able to calculate the accuracy of the proposed model. Okay. Now F1 scores. Again, as you can see, somehow F1 score will be depending on the value of precision and recall. So F1 score combines the precision recall of a classifier into a single metric by taking their harmonic mean. So in this case, this is the definition, right? And this is the formula in order to calculate F1 score for the given model. Okay. Now recall. Can you please give me a minute, Dilip sir?
Yes, sir. Audible, sir.
So someone is on the door. Can you give me 2 minutes?
Yes, yes.
Okay, just give me a minute. Sorry for the disturbance, sir.
Yes, sir.
Okay.
Possible.
The next metric is what? Recall. So as you can see, whenever you are able to draw the confusion matrix, you will be able to calculate the remaining metric performance metrics. So whenever you are going to whenever you are interested in publishing any paper in conference or any journal, so these are some common metrics that you should always consider. So again, as you can see, the value of the recall is somehow depending on the confusion matrix. So again, it will be nothing but TP divided by TP plus FN. So TP is true positive, TP is again true positive, and FN is false negative. So similarly, precision can also be calculated using this equation. And by using recall and precision, you will be able to calculate F1 score. The last one is receiver operating characteristic curve. So I will not be going into detail of ROC curve, but somehow the ROC curve can also be used to show the to evaluate the performance of the proposed model. So these the first 5 metrics are always important in order to evaluate the performance of any proposed model or some similar related work. So these are some these are some of the performance metrics that you should always consider at the time of writing any paper, right? So I also included some of the URLs as some resources that you can consider if you're interested working in the field of human activity recognition. So as you can see, actually I also started considering this particular blog where they have provided all possible information about the HER. They also talked about various type of data set. They also mentioned how the data set is acquired and what are the important features we can consider and what are the standard models we can start with, like CNN, CNN 1D, LSTM, convolutional LSTM, RNN, GRU, all those models can be used for the same type of data set. And for this particular type of implementation, UCI HR dataset was used. Okay, so as you can see, a gentle introduction to standard human activity recognition. So I also provided the link for the same, and all the resources have been provided by the same user. So it will be better for you to understand all those things, all those blocks one by one in the same order. So you can start with a gentle introduction to a standard human activity recognition, after which you can talk about, you can learn about various deep learning model that you can consider as a very first step if you want to deploy any deep learning model. After which you can also consider the scenario where you will be more comfortable to know how the data can be collected using any smartphone devices. Okay, and LSTM is one of the deep learning based model that have been considered for this particular type of activity. Okay, and after which evaluate machine learning algorithms for human activity recognition. So they consider various performance metrics in order to compare the performance of various models. Right. Similarly, you can also consider various deep learning based model and compare their performance using the same idea. So I think these resources will be sufficient enough to start with HAR for classification type of problems. Okay, there is also a possibility where you can also start with some reinforcement type of deep learning model for different type of activities where you will be predicting the fault detection kind of problem statement. But here we mainly focused on classification based problem where you will be able to identify different type of activities among available number of classes. So these are the references, and if you have any question you can ask.
Yes, participants, if you are having any kind of question based on this topic, you may ask on this. Please welcome. Is there any question? Anyone, please? You may ask. Okay, so thank you, Vaibhav sir,
Thank you so much, sir.
for your valuable time. Your expert talk has provided us with invaluable insights about deep learning based human activity recognition, which has wide application like sports injury detection, elderly care sector. You talked about HAR, its challenges, feature extraction, step involved in activity recognition process, and also about different public data set for HAR. I'm sure our participants have attained a better understanding about all these topics. Thank you again, sir, for taking out your valuable time to impart us with your knowledge. Thank you, sir.
Thank you so much, sir, for considering me. Can I leave now, sir?
Yes, sir.
Can I leave now?
Yes, sir. Yes, sir. Please.
Thank
Welcome.
you, sir. Thank you, sir.
So we will have just break for 20 minutes. आप online में you have to be online, but you may do your job till 3:10. Just come in front of the system by 3:10. No need to leave it, please. Okay, be online. So okay, you may do your job right now.
Okay, sir.